Good morning, everyone. My name is Mary Grace Gudia, and today I'm going to talk about the relationship and comparison of pathlines, streaklines, and streamlines. This is fluid kinematics pathlines, by the way. Before we proceed, let's talk about the learning outcomes. So, after completing this lesson, you should be able to first is identify the relationship between pathlines, streaklines, and streamlines. Second is compare streamlines with streaklines and pathlines. And third is determine the streamline pattern and acceleration field given a velocity field. Okay, so to start with, this is the relationship, by the way. Streamlines, streaklines, and pathlines are field lines in a fluid flow. They differ only when the flow changes with time, that is, when the flow is not steady. Okay? Considering a velocity vector field in three-dimensional space in the framework of continuum mechanics, we have that first, streamlines are a family of curves whose tangent vectors constitute the velocity vector field of the flow. These show the direction in which a massless fluid element will travel at any point in time. Okay, so for you to better understand what streamline is, I'll draw something here in my whiteboard. Okay, so I'm gonna draw a curve. Okay. So this serves as our fluid flow, okay? And this serves as our velocity. The arrow is our velocity. Okay, and since we are talking about streamlines, since it says there that streamlines are a family of curves whose tangent vectors constitute the velocity vector field of the flow, so we're gonna draw here a line, a broken line. Say for example, this is my house and I want to go to Gaisano. So these are the steps that I take. The broken lines are the steps that I take. Okay, when we talk about streamlines, guys, we are talking about unsteady or broken lines. Okay, take note of that and put that in mind because that is your that serves as your basis or ilhanan ninyo if unsa ang streamline. So I'll repeat, streamline are the unsteady or broken lines. Okay, so this is the streamline, if you can see, and this is the velocity. Overall, this is the fluid flow. Okay. Streaklines. Streaklines are the loci of points of all the fluid particles that have passed continuously through a particular spatial point in the past. Dye steadily injected into the fluid at a fixed point extends along a streakline. So since we have talked about streamline, we're now going to talk about streakline. So I'm not going to erase this because everything is related. Okay, so since streamlines are broken lines, streaklines are steady or continuous or straight lines. Okay, take note of that. And so when we say about streaklines, we are gonna combine the broken lines. Okay, so from broken or unsteady, it converted to steady, continuous, or straight lines. So from streamlines, we now have the streaklines. Okay, gets ra ninyo? Okay, so to differentiate again, once again, broken lines or unsteady lines are streamlines, while straight, continuous, or steady lines are called streaklines. Okay, streamlines and streaklines. Hope it's clear. And then we have here the pathlines. Pathlines are the trajectories that individual fluid particles follow. These can be thought of as recording the path of a fluid element in the flow over a certain period. The direction the path takes will be determined by the streamlines of the fluid at each moment in time. So since we have already talked about streamline and streaklines, we're now going to talk about pathlines. And what is pathline, by the way? From the word path, this is the direction that we take. Okay, so what is the direction here? I mentioned earlier, this is my house and I'm going to Gaisano. So the direction that I took is this. So, in other words, streak lines can also be called or determined as path lines. Okay? So, from this one, streak lines alone, ato i-add ang path lines. Okay? So if we're gonna put it to terms, like if we're gonna relate everything here, if we're just gonna talk about broken or unsteady lines alone, we are talking about streamlines. That's one. However, if we're gonna relate the fluid flow from the broken line being connected and the direction that we take from steady line, we have the streak line to path line. We're now gonna add the streamline here. Okay, so maybe maglibog mo, pero ayaw. Kung maglibog mo, ayaw. Okay, so yun na kayo na siya i-differentiate, guys. If we're just gonna talk about unsteady lines alone, we have the streamline. If it's steady, like this one here, since we have already combined or related every lines that we did or we drawed, so from broken to connected to the path that we took, we now have the steady line. Okay? I hope you understood. And for you to better understand, I have here provided a example or an illustration of a car. And there's also a description there that says a streamline is a line which smoothly connects velocity vectors at an instance in time. In other words, an image of the flow characterized by streamlines is like a snapshot of the flow at one moment in time. Okay, so if you can see the arrow there pointing to the right, that's called the velocity. That's a velocity vector, okay? And velocity is tangent to streamlines. And what is tangent, by the way? So tangent is touching but not intersecting a curve or curved surface. So to determine what a streamline is, just remove the blue line, okay? If we're gonna remove the blue line, that's called a streamline. And to sum it all up for you to better understand there, just kindly read. I have already explained that earlier from my discussion. Then we're gonna move to a streak line. Streak line is a curved line formed by a string of fluid particles which have passed through a certain point. An example of a streak line is a trail of smoke from a chimney. Okay, so earlier we just saw arrows pointing to the right and a blue lines. Now we only see two forms of arrows there and a straight line in the middle. So the straight line in the middle was the arrows earlier that was being connected. So now it's called the streak line. And then a path line is a path which a fluid particle traces. One example of a path line is the path defined by a balloon floating in the air. So from the arrows being connected, we now have the path or the direction that we took. So from left, we moved to right. That's the path that we took, and now we're talking about the path line. And we're gonna talk about equation of a streamline now. As you can see there, we have an example. So S stands for streamline, and since velocity is tangent, we have here the purple point arrow. And the displacement would be here we have the X, and here we have the Y. So if we're gonna derive our displacement, we will have here displacement factor is equals to xi plus yj plus zk. Okay, so x is taken from here, y is taken from here, and z is taken from the point. Okay, in case maglibog mo. So I, j, and k is the unit factors in x, y, and z directions respectively. And since in this displacement, we also have the velocity. So if we're gonna derive velocity, we have here v is equals to ui plus vj plus wk. Okay, so asa manin nato sila nakuha. So since we have velocity, u serves as the velocity for x, v serves as the velocity for y, and w serves as the velocity for z. For the velocity, we'll soon find out later after this slide. Okay, so let's look at this component here. If you can see the broken yellow line, that is our component or displacement, and there we have the u, v, and the k. In case mangutana mo asa gikuha, so diri nato na siya gikuha. And from the broken yellow line, we have u on the x-axis and v on the y-axis. And then on the right side, we have the tangent of data is equals to uv. But if we're gonna talk about the differential analysis from the distance here in the purple point to the curved line on the right, we have dx, and from the distance from dx to the arrow, the purple arrow, we have dy. So in other words, we can derive tangent of data equals to v over u. We can derive it to tangent of data equals dy over dx. Okay, and since both terms are related, so we can equate this. And if we're gonna equate that, we will have v over u equals dy over dx. So there we have the equation of streamline. I'll repeat, the equation of streamline is v over u is equals to dy over dx. Okay, thank you so much, guys. That is the end of my report. I hope you understood, and God bless always.